that I must have met you in a past life. Got my heart on the floor, go slow. Keep me falling for you all night. Tell me now, you're the one I've been dreaming about for my whole life. Had you on my mind, oh. Hear the sound of your voice in the crowd, calling my name, yeah, you captivate, oh. You captivate me. Cover me in a dream of love. You're pulling on my sanity, it does seems. I need you next to me, can't get enough. I don't wanna miss your energy. So tell me now, you're the one I've been dreaming about for my whole life. Had you on my mind, oh. Hear the sound of your voice in the crowd, calling my name, yeah, you captivate, oh. You captivate me, you captivate me, baby, baby. Ooh, it's almost too much to take. Baby, you captivate me. Ooh, with you's where I wanna stay. Baby, you captivate me. Tell me now, you're
Hello, everyone. Welcome to another incredible Workshop Wednesdays. We have the most amazing guest speaker again today, and also just a sprinkle of excitement. She's also from the Girls Who ML team, so super excited to have her. I know it's going to be a great one. But before we get into that, y'all, let me know where you are tuning in from. I saw some folks drop their flags in the chat, so we're super excited about that as well. And baby, it's the FIFA World Cup. What team are we rooting for? We got to see the flags. I saw so many Mexico flags. I saw Sweden flags earlier, and of course, I'm in New York City, so we had so many tourists pull in and pull up. So if you are watching the World Cup, if you are rooting for a specific team, drop your flags of the teams in the chat. Okay, Cape Verde, Egypt. Come on. I see Ohio. I thought I saw Italy. Also, I see some folks from, we see some folks from Nigeria. Folks are rooting for France and Brazil. We love that. Big energy on Brazil. I heard Messi was doing some good things. I'm not a huge soccer fan, but I'm definitely one of the bandwagon watchers. So we love that as well. So please, again, we're super excited to have you all. And we have an incredible, like I said, talk today. As we always do, announcements. As you all know, we have our Google Cloud Launchpad program. The applications for that close this Friday. So in 2 days. So make sure you all, if you're interested in joining, please make sure you submit your application. If you know of anyone else in your community, if you have any fellow students or other professionals in your network that are looking to level up their skills in Google Cloud technologies, we absolutely welcome you all. We have cloud foundations, data analytics, cybersecurity, and we also have some courses for enterprise agents, like developing agents, developing your own custom LLMs, and learning from the Google DeepMind team as well. So lots of incredible things here. Of course, those of you who are in our scholarship program, we want to say welcome. Please make sure that you follow the instructions for your attendance for today as well. If you are unsure of what that looks like, please just go ahead and visit our Slack channel. I went ahead and put some posts in the Slack channel for you all to lean into as well. Please make sure you tell your other scholars that we are live as well. Tell Lottie, Dottie, and everybody. All right, y'all. I'm super excited. Like I said, we have an incredible speaker today. We have Ipshita Chattery, who is a research engineering manager at Thomson Reuters. So we're super excited to have her. She leads the research engineering team with foundational research, building world-leading legal large language models that are transforming how legal professionals access and interact with knowledge. With more than 7 years of experience across AI, machine learning, and large-scale production systems, Ipshita has built her career at the intersection of cutting-edge research and also real-world impact. Her background includes work across some of the most incredible innovative technology organizations where she helped bridge advanced AI capabilities with products used by millions. Um, I believe Amazon is one of those companies as well. She's just been doing incredible work. And so it's such a pleasure to have her. And like I said earlier, in addition to her incredible industry leadership, she serves as the head of learning at Girls Who ML. So she is on a mission to help develop the next generation of machine learning talent and, of course, help to expand access to AI education and opportunities. So please join me in welcoming the most amazing Ipshita.
Hello, hi everyone. How are we doing?
Hello, hello, hello. I'm super excited to have you. How is your week going?
Pretty good. It's finally great weather here in London, where I am. Last week was quite warm, but looking forward to a bit cooler days.
I
So
love that. I love that so much. I personally have been looking forward to this summer because I feel like in New York it was just a very long, dragged out winter season. So for me, summertime means lobster rolls. It means lakeside views and just some relaxation, maybe some road trips as well. So I'm super excited.
yeah, definitely love summer. Love the long days. Love like all of the social life, everything.
Absolutely. So, as you may or may not know, we always play a game of this or that before we jump in, or at least for the last couple of sessions. I would love to continue the momentum. Are you ready?
Yeah, let's go for it.
Okay. So, first question: would you rather build fast or build perfectly?
But first.
Why?
Because at least for me, and a lot of times we spend a lot of time trying to get things perfect without kind of understanding what might be needed or how it might be perceived out there. So I think it's better to get things out there fast and see and learn from the feedback rather than spending a lot of time iterating on something. So it's a way to get feedback faster.
Amazing. I think those are really great questions as well. I think I want to align with that too. I think I would definitely choose that as well. Next question. And also for those of you who are tuning in, please, we would love to hear your feedback as well. Let us know if you prefer to build fast or perfectly, and of course for the rest of the questions. So next question: do you prefer receiving or leveraging user feedback versus starting with product intuition?
Hmm. I think personally, leveraging feedback, like I mean, there's just something very interesting about learning about people's organic thoughts and like pain points, what worked, what didn't work, or what they would want to, do more of, things like that, and building around that. And I think that would be like a good place to start for me.
I love that. And of course, that is a very research wounded answer as well. Of course, the users always can tell us what's working, what's not, and of course, where to align our strategy. In the same vein, do you prefer like B2B strategies or B2C strategies, business to business or business to consumer?
Hmm. I haven't given that much thought. Um, I guess I don't have a preference because I don't know enough about this.
Okay. Okay, cool. Next question. Would you rather product led growth or sales led growth?
Product-led growth,
Mm,
because I think building great. We are at a point in time where building great products is easier and easier than ever. So I guess with a good combination of product intuition and feedback, like whichever order you might want to go about it, can lead us to like great growth outcomes.
I definitely want to align on that too. I am such a product girly as well. And of course, that allows us to have a legacy of a roadmap of, like, continued users, usability, and hopefully become something that lasts beyond yourself. Also, next question: do you prefer the MVP launches or the extended beta launches?
I guess an extended beta, because I just said we would like to get as much feedback as we can. So an extended beta would be a good way to do that.
Okay, I was going to align with that too. I like the extended beta because it allows us to add a little bit more surprise and delight into the user experience. Obviously, MVP can sometimes be stressful just to get out there, but once it's out there, now we can focus on more of the fun stuff.
Yeah, and we'll
Um,
go into more details about how MVPs can or can't scale in a bit. So,
I agree. I absolutely agree. Okay, changing gears a bit. Would you rather, or do you enjoy most or more of the learning from failures or past opportunities, or learning from success?
learning from failures, definitely.
Mm,
I think I've had my fair share of them, and I think they kind of teach you very important lessons. And if you can kind of internalize it, they, I think, stay more with me rather than the successes.
mm, I love that. Um, would you prefer more time or more money?
Oh, more time.
Mm, I align with that too. In your, I guess, as you've sojourned your career in tech, which do you think is most important, having influence or expertise?
I guess that depends on what stage of your career you are in. I think early career folks would do well by building their expertise, and expertise can then compound to influence. So, influence without expertise, in my experience, may not be as well received.
Wow, that is really good. Love all of that. Nothing to add there. And our last question before we go ahead and give you the baton. Um, if you were to describe yourself with one of these words, would you say that you are a visionary or an operator?
I'm a visionary.
Hmm. Why would you choose visionary?
Um, I just feel connected to it. So I'm like, personally, for me, I'm very excited with the advent of the ease of product building and coding tools and so on. So because allows me to execute on my visions a lot more frictionlessly. Yeah. So I. Yeah, it's just how I feel. Like I really relate to that on a personal level.
I love that. I love that. Well, thanks so much for indulging me in this today's round of this or that. I
Loved it.
will go ahead. Oh, thank you. I'll go ahead and give you the baton. Over to you.
Thank you, Chanel. Yep, let's get started. Brief introduction. I wouldn't spend a lot of time on this. We already spoke. Hello, hello. Welcome to today's Workshop Wednesday session. As you know, Girls Who ML and Mentor Me Collective have been partnering on this. I'm Ipshita Chatterjee, and today we'll talk about one of the biggest bottlenecks in real world machine learning systems: how to ship a model from research to production. If you've spent weeks tuning a model into beautiful validation accuracy or beautiful metrics in a Jupyter notebook, only to watch it break the second you try to share it, or crash when you put it into a system or an API, you are in exactly the right place, and we're going to talk about that. We'll discuss the operational aspects of ML engineering today, things like automated testing, containerization, and the safety gates which prevent production disasters. Tiny bit of background, like which we've already covered. As Chanel said, I'm research engineering manager at Thomson Reuters Foundational Research, building advanced legal LLMs. Previously, I was at Amazon HAI when I worked on the Amazon Nova speech and audio models. Overall, I have over 7 years of experience across software engineering, machine learning roles, and my key focus has been bringing these two together to bring emergent research, innovative technologies to millions of users worldwide with high efficiency and reliability. I completed my MSc in computer science from University of Oxford, and I specialize in machine learning. And also, I'm incredibly passionate about tech accessibility and representation, and that's also why I serve as head of learning at Girls Who ML. And this partnership has been very exciting for us, and hope both our communities have enjoyed it as much as we've enjoyed putting this together. And the lessons that we'll discuss today are not purely academic. They are the exact problems that you would encounter in your day job or even in an interview setting. These are standard industry practices which keep models fast, reliable, cost efficient, and secure under massive traffic. So let's start. You have a model from the research team. You're on an engineering team, you have a research team that works with you, they give you a model. The research team has just spent months tuning a beautiful state-of-the-art new architecture. They've finished training, evaluations, and now they've handed off the artifacts to you to deploy. Everyone's very excited. People can't wait to get this to users, get this on your application, all good things. They show you the notebook, they hit run all, the curves look beautiful, the metrics look great, and it finishes executing cleanly. On their local GPU with their local packages, all looks great. You feel confident. Okay, this all looks great, and you're tasked to, now roll this out to users. You try to containerize it. You try to integrate it into your service, hook it up to your existing system, or host it on a cluster to handle incoming traffic. You write the wrappers, you spin up the server, point a request at it, and so on. But that's when everything catches fire. Standard software libraries might mismatch, CUDA drivers might clash with the Linux kernel, the server times out, your API returns a 500 internal server error because there was a NaN value at a pre-processing step. And even if you work through all of this, when it finally runs, the outputs are nowhere close to what the research team showed you on their machine. And you're left sitting there days into debugging, looking at a stack trace, repeating, but it worked on my machine. I think that's happened to more of us than we would like to admit. And believe me, this is very common. But why does this happen? So let's break down the fundamental difference between research exploration and production engineering. In the research and exploration phase, your metric or the team's metric is research velocity. You are experimenting rapidly. You change variables dynamically inside a running notebook. You pip install libraries on the fly, and your target is accuracy on a usually static set of benchmarks. But even with a large suite of benchmarks, you kind of know what you are looking for at that point. But production MLOps is an entirely different sport. It demands immutability. You cannot have your environment shifting under your feet. You need completely isolated container environments, frozen and reliable API contracts, automated tests, and safe and reliable deployment routes. In production, often a slightly less accurate model that is robust, fast, secure, reliable will most certainly or most likely win over a hyper accurate state of the art model that is fragile and crashes the host or the system under load or traffic. In today's session, we will focus on three concepts or takeaways. First, understanding containerization. We'll discuss how tools like Docker package environments to completely eliminate environmental drift. Second, we'll talk about CI/CD gates. We'll outline the automated tests required to block out bad code or degraded models or any any of this sort of changes going from ever reaching live users. And third, we'll learn how to route traffic safely. And we'll kind of go into an exercise and see how we can do that and see what you folks think. So why do we want to do all of this, right? So this is quite a bit of work. So what does MLOps or these MLOps technique, what do they offer us? Firstly, runtime parity. This is how we kill it works on my machine or it works on their machine or whoever's machine executes. We want the exact same environment running on your MacBook or your laptop to be running on your AWS or Google Cloud or Azure server. Second, safety gates are very important for any kind of production environment or application. If the model starts giving garbage outputs or fails to load, the system shouldn't crash. Your automation and your safety gates should have got it, trigger an alert, and automatically roll back to the last known stable state. So your users would ideally never know something like this happened. And third, this promotes the concept of continuous life cycles. Nobody should be manually uploading code and models as static artifacts to the target environment. These MLOps techniques build predictable automated loops for updating and monitoring models in ML systems real time. So before you write a single line of code, these are some questions you need to ask yourself, you need to ask your team, and think through before you kind of design a system that shifts ML models to production. First, how are dependencies handled? How are we freezing Python packages and CUDA drivers into a point-in-time representation? What about pipeline validation? What programmatic checks must this model pass before we even build a container? What is the rollout risk? If something goes wrong, what is the blast radius? How many users, which users are impacted? How much user traffic are we routing to the new candidate first? Is it 100%? Is it 5%? Something in between? And fourth, what is the retraining floor? When the world around our model changes and our model decays, so it doesn't perform as well, which metrics do we have that will trigger an automatic rebuild? So these are some very key questions that you need to think about and answer before you can actually go ahead and even write a single line of code. And to address these four questions, we rely on three core techniques. We are going to walk through them step by step. Like I said before, containerization using Docker, CI/CD pipelines, which kind of enforce this automated validation of code and models, and canary deployments, safely managing live user traffic. Let's start first with containerization. Basically, containerization answers the question, how do we freeze the environment so that it never changes, regardless of the physical server that it runs on? Let's start with a basic introduction to what Docker actually is. So if you've never used it, think of Docker as a standardized shipping container for software. Before shipping containers were invented, cargo ships had to be loaded with loose barrels, crates, and sacks. It was incredibly slow, and things broke constantly because every item was a different shape. Shipping containers revolutionized global trade by standardizing the box. No matter what's inside the box, whether it's bananas or auto parts, The cranes, ships, trains, and trucks can all handle the box in the exact same way. And Docker does this for code. It packages your Python files, your weights, your server, system utilities, and even GPU drivers into a single standardized, unshakable box called an image. When you run this image, it becomes a container. It's a completely isolated, lightweight sandbox. So that's different from a virtual machine. A virtual machine has to also package a whole guest operating system, which is heavy and slow. Docker shares the host operating system's kernel, and it starts up quite quickly. While Docker is the industry standard, there are a few similar other tools you might come across. Podman is an alternative and Containered, but it's very common to be using Docker for these purposes. So the advantages of this approach, as you can think, are massive. So really a true environment parity, rapid scaling, and isolation. So nobody cares what's inside the box itself runs. But having said that, as engineers, we must always understand the trade offs. Deep learning images are heavy. A basic PyTorch image can easily be 5 to 10 gigabytes, and transferring these files over networks slows down deployment times, and container initialization adds runtime overhead. So these are some things that we should keep in mind when we are kind of designing Docker images or creating Docker images. Okay, let's take a moment in the chat. I want to hear your thoughts about these two questions. Let's start with question one. Why is storing large model weights, say a 10 GB neural network, directly inside a Docker container generally considered bad practice? So drop your thoughts into the chat on why would you think this might be a bad idea.
Okay, some folks are saying maybe it's too large.
Yep, that's in the right direction. Yes, like we just said, basic PyTorch image can easily be 5 to 10 gigabytes. And if you bake model weights into the image, every minor code change would require rebuilding and pushing a massive 10 GB file. So instead, what is normally done is we keep the container small, and we tend to pull the weights from an external storage bucket like AWS S3 or something like that at startup, and then cache that locally. So yeah, that's absolutely right. It is too large to be built into the image. Okay, next question. What happens if your local development laptop compiles the libraries you need on Apple Silicon, but ARM64, but your production servers run standard AMD 64 Linux? So basically, two different environments of running your code. So what might happen?
Okay, just waiting for some other folks to join or answer that question in the chat. We still see some from the previous question. And while we get answers for the second question, Dennis has a question. Other Docker images can share the model weights, right?
If they have access to the location that you've set it up to be, then yes, but you could restrict access and set it up in a way that that is not the case.
Awesome. We have some other answers for question two. Some folks are saying runtime errors.
Yeah, that is right. That is right.
It is run. Sorry, didn't want to cut you off. I was going to say some folks had thoughts around formatting, maybe incompatible systems, maybe the code contains errors, no updates. Yep. Yes.
Yep, the answer is errors. It is errors, and errors of all kinds. So incompatible systems, runtime errors, all of them right answers. That's absolutely right. It will probably crash with binary execution errors. So that is why we configure our CI/CD pipelines to build images targeting the destination architecture, regardless of what our laptop runs. Cool. Very nice answers. Thank you so much. Let's keep going. Let's move on to our second pillar, CI/CD and automated gates. So once we have a container, how do we automate the testing so that no broken code or degraded model ever reaches a customer? So for those who are not familiar with the term, CI/CD stands for continuous integration and continuous delivery or continuous deployment. Think of CI/CD like highly automated factory assembly line with quality control inspectors at every single station. When a worker finishes a part, they don't manually walk it to the packaging department. They place it on a conveyor belt. As it moves down the belt, robotic sensors check dimensions, scan for micro cracks, and reject it if anything is wrong. If it passes every checkpoint, it gets boxed and shipped automatically. So that's exactly what you would want your CI/CD pipeline to do for your code and models. So in software engineering, the conveyor belt is our CI/CD pipeline, and you usually set it up with tools like GitHub Actions or GitLab CI. And some examples of what this might look like in practice. For CI, anytime a developer commits a line of code, the pipeline automatically spins up a clean, isolated container. It runs some style linters, so check for any formatting errors to make sure that's okay. Run some security scanners to check for any leaked API keys or secrets, things like that, and execute unit tests to make sure our logic still works. And continuous deployment. So if and only if every single test on the line passes, the pipeline automatically packages our code into a Docker image and then pushes it onto the staging and or production servers without any developer having to drag and drop files manually or ever uploading any artifact manually to your target host. So this is fairly standard for those of us with a bit of software engineering experience. This might be quite standard, and this is like very widespread practice across the industry. So how does this process change when we introduce machine learning, and how does this change for ML systems? Let's look at how we would build programmatic testing pipelines, specifically for ML. In traditional software, a test might verify if I pass in a string, does the function return a string? In MLOps, we divide, we can think about tests in three categories or three programmatic gates. Sanity tests, these check if our data processing pipeline is robust. Does it handle missing values, NaN values, empty strings, or does it throw an exception and crash the server? Second category would be functional tests. We pass a mock and dummy vector to the model. Does it return the correct tensor shape? Are the values non-zero? This verifies that the model is loaded and is working as an API. And third, and probably the most important one, where most time and effort of teams are spent, is quality gates. This is the ultimate benchmark. We test the model candidate against golden held out validation set, and increasingly with more and more complex models, this tends to be a huge suite of benchmarks and capabilities and functionalities that you need to verify quality against. So this tends to be quite an elaborate step. So if the accuracy or performance drops below our current baseline, or if the latency is too high, the pipeline automatically blocks the build. So let's go back to the chat and take a minute to think like ops engineers here. So question 1, your pipeline passes and all your mock unit tests succeed, but when deployed to live users, the system crashes immediately. What might your testing suite have missed? And for this one, there is no one correct answer. So I'm looking forward to all your thoughts and anything that you think might have gone wrong here.
Okay, just waiting for some folks to put some thoughts in the chat. Um,
Yep, no one correct answer. So just like go wild with your guesses.
cool. And we're asking them to answer the first question, correct?
Yep.
Awesome.
So
Awesome.
things looked good when you set up your tests, but they did not look as good when your tests passed and things went into production, things crashed. So what might be missing in your tests? Why did they not fail?
We had one person say maybe user feedback.
That is along the right lines. Maybe a bit more.
Awesome.
So remember, our pipeline or our tests only exist because we've created them. So that means that they did pass. So we've only tested for certain things, and we may not have tested for different scenarios. So I'm seeing someone saying multiple scenarios. That's along the right lines. Yes. We might have missed some scenarios. Yep. Good stuff. Yep, all of these are possibilities. Yep, we should have done a smoke test. Yep. Okay, so great answers. Like I said, no one right answer. Some of these are right on theme. This might happen when our test data did not capture real world scenarios, or traffic patterns, so such as out of bounds or invalid user inputs. Might crash due to network latency spikes or schema mismatches in database queries and a variety of reasons. So, yep, and that's why integration tests, smoke tests, and canary testing are vital. And we'll go into that in a moment. Cool. Let's do question number 2. Should we execute full-scale ML model training inside a basic GitHub Action CI/CD runner machine? Why or why not? So just as a reminder, we just talked about CI/CD pipelines as the conveyor belt of our ML production pipeline. So that checks for linter errors, unit tests, and things like that. So do you think this kind of a setup in using GitHub Actions, for example, would be good for a full-scale machine learning training? And with why or why not, also drop why do you think that is the answer? Runtime issues? Yep. So remember what we said. This is we want our actions and CI/CD to just be an inspector of sorts and just check. Yep, absolutely. It is cost expensive. That's right. CI/CD runners are just helping sanity check our code and should not be used for ML training. So, yep, that's the right answer. We should not be using this for ML training. So, CI/CD runner nodes are small virtual machines typically without GPUs. Running heavy training on them will either time out or rack massive runner costs and most likely not be able to execute at all. So we might use CI/CD to trigger the training on a dedicated cluster like Kubernetes or SageMaker, but we never run the training work inside the runner itself. So yeah, a lot of people got this right in the chat. That's great. Cool, let's move on. So coming to our third pillar of MLOps techniques that are typically used is deployments. We've been talking about that a bit. Once our CI/CD pipeline has verified our code and packaged our Docker container, how do we release it to live users without risking downtime? Let's talk about canary deployments. And to understand this concept, I have a bit of a history tidbit here. This phrase comes from the historical practice of bringing a canary into a coal mine. Miners working deep underground faced a major hazard: silent, odorless, toxic gases like carbon monoxide. To protect themselves, they carried a canary in a small cage. Canaries are highly sensitive to trace amounts of toxic gas, and if the canary stopped singing or collapsed, miners knew immediately that gas was leaking and evacuated the mine instantly. So this was something I learned while preparing for this presentation as well, and thought would be interesting to share. In modern software development, canary is a small isolated slice of real live user traffic, usually only 2 to 5%. So the idea is, instead of rolling out a brand new model to 100% of our users all at once, which could result in a catastrophic system crash if something is broken, or maybe users seeing degraded model performance, or seeing the model give bad answers, garbage answers, and so on, we roll it out to a very small percentage of our users. So let's say 95% of our active users look at our old reliable baseline model, and only 5% to our new canary model. We then monitor the canary's performance metrics very closely. We check for metrics. Is it throwing 500 errors? Is it causing any massive latency spikes? And if the canary crashes, a very small percentage of our users are impacted, which is a very small blast radius. We can instantly roll the traffic back with zero user-facing downtime. And if everything looks good, metrics look stable, fast, accurate, inference looks good under real-world load, we gradually scale up the traffic split until it handles 100% of our production load. And that's typically how most rollouts happen, so that we contain our blast radius, and we kind of roll this out very slowly and with monitoring at every step. Okay, let's do a small activity again. So we've built this brilliant new candidate model. Things are looking great. All of our previous steps are okay. And we now deploy it as a canary, routing exactly 5% of active live production requests to it, while keeping 95% of our old stable baseline. And let's look at the dashboards that came up. Card 1, so the one on the top, showing our P99 latency. The canary is responding in 180 milliseconds, while our baseline is at 45 milliseconds. And the one below that shows our accuracy. The canary is at 92%, while our baseline is at 90%. And I want you to drop in chat option 1 or 2, so just drop 1 or 2. Option 1, roll back the canary immediately. Option 2, promote canary to 100% user traffic. Yeah, go. And why would you think either one? Option 1, roll back. Option 2, promote to everyone. And any thoughts on why? I'm seeing a mix of answers here. So anybody wants to talk about why, either 1 or 2? 1 is rollback, 2 is promote to 100%. Why do you think it might be either 1 or 2? Okay, I'm seeing a lot of ones, which means rollback. Yes, the correct operational decision here is to roll back immediately. And why is because even though we have um, good accuracy, it went up by 2%, our latency has quadrupled. In high traffic systems, a 4x latency spike can trigger cascading network timeouts, can degrade your user experience, can cause downstream services to fail, and it can violate your company's SLAs, which are service level agreements. So, the idea behind this is accuracy is never evaluated in a vacuum. It exists within other constraints of the system. So, in this case, hardware constraints and latency constraints. But yeah, a lot of you got this right. Yes, we roll back in this case and understand why and look into why this latency is spiking and what we can do to fix it, and then come back with that fix. Cool. Let's summarize what we've covered so far. This overview. Every technique that we've discussed has both costs and benefits. So Docker provides a low cost, low risk way to block environmental drift. But sorry, it doesn't protect against. Sorry. So yeah, Docker is low cost, low risk, blocks environmental drift, but doesn't protect against logical code regressions. CI/CD tests carry a medium cost to write and configure, but they are your shield against code and model regressions. Canary deployments have a low blast radius risk, but they are expensive to implement because they need this kind of infrastructure to balance this load, like we discussed, and have that proxies. And overall, active monitoring is the gold standard for tracking system health, and that also requires quite a bit of investment through telemetry infrastructure. Okay, so final takeaways. Environment parity, never assume it's going to run safely in production until you've containerized it and matched the execution, a host execution environment. Enforce verification gates, build sanity testing around what goes into your system to prevent silent failures and block pipeline progression and rollbacks until all your checks are green, and protect your users from bad models by rolling out traffic incrementally. And yeah, let's open this up to questions.
Okay, awesome. Thank you so much for an incredible session. Definitely, yep, want you to take some time. We're so sorry. Um, yeah, take some time to put yourself. Just want to say, everyone, as you all see the links here in the chat, you all can definitely reach out and connect with Ipshita on LinkedIn. And of course, this is her email directly for Girls Who ML. So if you have any questions about that or how to become a member of the community too, please feel free to reach out and connect in that way. Q&A, Q&A, Q&A. So feel free to drop your questions in the chat. I'll make sure to star them as they come in. Let's definitely thank Abshita. Yeah, it was an incredible, incredible session. Okay. So as your questions are coming in, for those of you who are scholars, that is a part of the attendance today, make sure that you drop a question. Our first question comes from Jimmy. What are the challenges of deploying machine learning models continuously compared to software?
That's a really, really good question. So, like we talked about, ML models have, so a lot of these are standard software engineering practices. So, CI/CD is very common in software engineering teams. But with ML models, you have the additional challenge of model weights, data inputs, and the fact that you might have to monitor this not only on a network level or an infrastructure, an application level, but also ML related metrics. So things like, is your model still meaningful? Does it respond correctly, or does it do what you trained it to do, or even is the training even relevant anymore, and things like that. So that's kind of an additional layer on top of what you would be doing for any software system normally. And as models get more and more complex in the LLM world today, that complexity is only rising. So, like I said, evaluation metrics, it's a huge area of work and research across companies who are doing this. A lot of work goes into making models suitable and kind of tweaking this and improving them continuously.
Amazing. That was an incredible answer too. I hope that answered your question, Jimmy. We just had more folks just saying this was a great presentation. Thanks so much, everyone, for all the love that you're sharing. We have another question that came in the chat from Dennis. Were there any common issues you saw with deploying machine learning models?
To be honest with you, I've seen all of them, the ones I talked about. Network crashes, libraries mismatching. But I think one of the common challenges for setups that do not have these things, or maybe are starting off a bit early, is ML issues might be very hard to trace back. So once you've kind of isolated, like ironed out containerization, and your environment issues, application issues. Often, in my experience, you might be running the model in a different host or an environment, but it runs, but it does not give you the same performance that you saw in a research environment. And those kind of issues are very tricky to address. If you don't have these kind of sanity gates and these metrics and evaluation gates that I just talked about. So increasingly with more complex systems, it's harder to trace back which capability regressed, or which aspect of your model is not performing as optimally as your previous baseline. So these are like very common issues which teams work through every day. And honestly, I have been on this side of an endless debugging many more times than I would want to admit, and I've been the this is fine fire situation a lot of times. So yeah, all of these are very common issues that occur, and many of you might come across these in an interview scenario or your day-to-day job, and it's good to keep these best practices in mind.
Amazing, amazing. Next question from Zacharias. It's like, what's the biggest ML machine learning ops mistake you see solo developers make?
That's a very good question. I need to think about this a bit more, but off the top of my head, as a solo developer, maybe because you are not working in a multiple team setup, it is possible that you think that you may not need this kind of an elaborate, containerization, CI/CD deployments, pipelines, or even these kind of deployment strategies. But like we discussed, all of these are to regulate and control, like change management. So you're basically managing how you roll out ML models. And while that's compounded when many teams and many developers are working together, it's an issue you could run into with your own changes feature after feature. So it's I mean, as a solo developer, also, these are very important to keep in mind, even though you might not have team members working with you.
Amazing. Our next question. What advice would you give to someone who wants to pivot to machine learning, but only has a background in software engineering?
Great question. I think already with the software engineering background, you know quite a bit, and you know the basics, and you might understand a lot of these things. Exposure to ML is a layer on top of it. So I would recommend being inquisitive, learning, and don't be intimidated by complex concepts or very technical words, things like that. Try to understand what the concepts are, what they talk about, what problem they're trying to solve, very much so like you would be doing in traditional software engineering. And there are a lot of resources and communities out there, Mentor Me Collective, Girls Who ML, a lot of people doing great work out there to reduce barriers to ML education and leverage the use of community, because yes, this journey can get quite isolating and you don't have to do it on your own.
Amazing. Thanks so much for that question. We have another question in regards to resources. So, what are some resources that one can explore for beginners to learn about machine learning models and maybe the common issues that arise, especially as they become more complex?
So there are a lot of blogs and newsletters out there. I can Latent Space comes to mind. It's a Substack newsletter. I can send more across later to the community. But yeah, there are quite a few resources out there. And what I've recently started doing to keep up on top of my reading is ask your favorite LLM to summarize it, and then kind of ask you questions on it. So previously, it was like, I think all of us, I had an endless reading list. Which I couldn't keep on top of. But recently I've kind of started doing that. And for interesting papers, I spend my papers or articles, I would just spend some time going through them. But and if you feel some of the concepts are more complex, just ask your favorite friendly LLM to summarize it, and you might be good to go.
Amazing. I went ahead and just dropped the link to Lightning.space. They have different models, but definitely there's a free tier that you can join. So thanks so much for highlighting that as well, Ipshita. Cool. We have another question in regards to someone who wants to transition into machine learning. So what advice would you give to a data scientist who wants to bridge the gap and learn about the engineering side of machine learning?
Great question. And I think already as a data scientist, you are dealing with a lot of the practical sides of the ML development lifecycle. So you're probably used to messy, real world data, unstructured, and you're probably putting in a lot of work to clean up the data, make it usable for training or gaining meaningful insights out of it. So all of these are transferable skills and concepts to the ML development lifecycle. So I would say that's already one aspect of ML engineering. Quite a bit of overlap there. So and to learn about more on the other side of things like deployment, monitoring, optimizations, and so on. I think try to look out for stretch projects in your organizations. So if you're already working as a data scientist, try and find out which teams might be working on these topics. Try to find mentors or other people who might be working as MLOps engineers. Meetups and hackathons are always a good idea. And try to build your exposure. But coming from a data science background, I would say you have more exposure to this than a lot of other backgrounds already.
I love that. All of these are super incredible insights, and I hope that was beneficial as well. We have a lot of incredible questions. One question from John says, "What advice would you give someone who is in cybersecurity but may want to pivot into machine learning?"
Oh, that's so nice. I think cybersecurity and machine learning or AI safety, AI alignment research is one of the hottest fields, hottest topics in the field right now. So if you're considering this move, I think no better time to do this, because a lot of these questions are being asked and being answered or trying to be answered. So I think this is a very good time. So no advice, because I'm not a cybersecurity scholar myself, but maybe just apply these principles into the systems and try to ask questions from first principles, and kind of as you would do for software systems. So, but I would say definitely one of the biggest questions in the industry right now. Chanel, I think I lost you audio.
Okay, can you hear me now?
Okay, you're back.
Okay, awesome. We have time for maybe one more question after this, but this question says, I'm pretty comfortable with building models in notebooks, but I want to get better at the deployment side. So what skill or tool do you think I should focus on mastering first?
So definitely explore all of the concepts that we discussed today, read more about them, see how they might be implemented in any open source repositories, or a lot of ML teams and software engineering teams write blogs about this stuff. So there are a lot of ML engineering blogs you could look at, and look at how your favorite product, your favorite social media feed, or how your favorite AI powered feature might be doing this. So there are a lot of very good ML engineering blogs. So maybe start reading those and start learning about some of the tools or techniques they might have used. A lot of these are the same underlying principles. But having said that, this is also something you learn by doing. ML engineering is definitely learning on the job, or learning by doing discipline. So try and find opportunities to get your hands dirty, and try to see more and more of these errors, and try to work your way through them.
Amazing. Well, we just hit three. So I do want to be respectful of our wonderful speakers' time. I just want to say thank you so much for all of your insights, your vulnerability, your openness of what you shared. The entire community is super excited, and this was such an incredible presentation. Is there anything that you would like for us to, if there's one thing that you want folks to leave from today, what would you want them to leave with?
First of all, thank you, Chanel. Thank you, everybody. I'm glad you found this helpful. Feel free to connect, and we can discuss more. And this has been great from both Girls Who ML perspective as well. One final thoughts, I would say that it is often intimidating, it is often overwhelming, and somehow it never stops being the case. So I guess you only need to take the first step, take a step back, think about things, think about all of the things you asked me from first principles, try to identify how your existing skill set already fits in, and you will kind of forge your way from then. So take the first step, ask questions, be curious, keep learning, and things will happen.
I love that. And again, for those of you who did not capture it, just go ahead and take a screenshot. Here, this is Ipshita's LinkedIn. And also, if you want to send her an email or connect, maybe learn more about her background and her story, feel free to shoot her a request in that message. Thanks so much, Ipshita. We thank you so much for all of your time. And we want to say au revoir. Until next time.
Bye-bye. Thank you.
Bye. All right, everyone. We're super excited. Today in this workshop is our last workshop for the summer with Girls Who ML, but we will be kicking things back for the fall. In the meantime, in between time, we will still have a workshop, so make sure to tune in again tomorrow on Wednesday for our next workshop. Again, please make sure that you connect with Ipshita and reach out. I know a lot of you all have interest in machine learning. Maybe you have different career paths as well. And so it's super important to connect with professionals who not only are in the space that you want to be in, but also has a lot of experience. So you can learn from their journey. Wishing you all a wonderful rest of your week. Looking forward to seeing you all next week. And until next time, bye everyone.
Think I've been here before. I know that I must have met you in a past